Okay. So 72%, that's the amount of AI agents that fail in production. And that's 2026. The leading reason is not the prompt or the model. It's actually the plumbing. Good evening, everyone. Welcome to my talk, Agents in the Wild. Today, I'll walk you through my journey of building the first AI agent at PhonePe and the lessons learned along the way. So a little bit of background. This was around a year back, early 2025. AI agents were comparatively a new concept, and I wanted to solve a real-world problem. So among other things, I closely work with the trust and safety team at PhonePe, and I chose a problem that was close to them. The team, one of the core tasks of the team is to investigate suspicious entities. These are users, merchants. They investigate these entities for known fraud MOs and take actions to mitigate the risk, right? So our investigation typically looks at roughly like 40 to 45 number of known MOs, and then they take a verdict, which guides the decision that we take on the entity. Um, So I picked this problem. It sounded like a good problem to me because there were moderate stakes and there was a tangible impact. If I could automate the investigations, it would um, it would free up the bandwidth so that the team could look at finding new fraud patterns, right? So I got started. Um, I had a decent sized corpus of past investigations. These investigations contained the data that the investigator looked at, the investigator notes, and the final verdict, right? So after fiddling around with the prompt for a couple of days and vibe coding my way out of a UI because I can't write UIs, I had a POC at my hands. I demoed this to the team, and the team find it actually got intrigued. They agreed to tune the agent with me, right? Um, we gave it another 2 weeks. We incorporated all the feedback that the team had, and we had a decently working agent that was able to solve the cases that we had. Um, Before putting it in production, we wanted to actually test out the efficacy of the agent. And so we decided to put 10% of the production traffic through this agent and judge the investigation quality, right? We recognize a lot of issues with this because there were a lot of investigation notes didn't have all the aspects of the investigations. So the agent couldn't actually comprehend a lot of fraud patterns. We actually incorporated these manually, and after 2 weeks, we decided to actually put it in production. This is obviously a lapse in judgment, but the team had actually come to me with two big thumbs up, saying the agent is working perfectly fine. It's doing a better job than half of the team. Let's put it in production. And obviously, it didn't really go very well. We had an unhinged agent throwing tantrums every day. Context limit breaches. These investigations inherently are very complex. It's roughly a 20 to 25 step workflow. So you could think of long horizon coding tasks. It was a similar situation, and we ran into context limit breaches. This was a funny one. The agent returning the risk score in cursive out all of a sudden, 0.9. And overall incoherent outputs. The agent returned a 5-liner explanation of why the entity is clearly a fraud case, while returning the verdict as not suspicious. The band-aid phase. We tried to prompt our way out of the situation. Obviously, this didn't work. We could fix one part of the investigation, but it broke another. It was a game of whack-a-mole. Somebody suggested better model, right? Like use O3. There's the engineering analogy of throw more hardware at it. I never liked that analogy. We tried multi-agent. You have to take in the context that this was early 2025. Multi-agents were developing at that point of time, and when we tried them, it actually worsened the situation because the context limit breaches happened earlier in the pipeline. At this point of time, I borrowed an idea from Shantanu's page. Um, we decided to completely pivot. We stripped down the AI agent framework that we were using at the time and decided to write the agent loop ourselves. This was the simplify phase. To make sure that we don't have so many errors in production, we decided to add a comprehensive validation layer. This not only helped us know that there are failures, we actually relayed back the errors to the LLM, and it actually fixed it in a lot of cases. This overall increased the reliability of our agent. And finally, we worked on context engineering, right? This is a very thrown around word, but we did a bunch of things to optimize the context. So here is how the agent works actually. We give it an investigation manual, which we generate from the past investigations that we have seen to work, right? We give it the tools that it needs in terms of fetching internal data and running open source intelligence workflows. And we give it the actual case data. So in this case, we started off with the investigation manual as a generic markdown file. And at this point of time, we converted it into a schematized JSON plan. This really helped us minimize the context. We also created in-memory objects instead of fetching all of the internal data at one go. We gave it functions to fetch logical objects that it would need for the current investigation step. Lastly, evals. We set up a golden data set of the past investigations, which we knew were right. We set up metrics on precision and recall for different type of verdicts, and we optimized for that. And we set up reasoning similarity. We compared the agent's reasoning traces to the actual investigator notes to know how much is the agent thinking correct, right? This was important to know if the agent would actually generalize well. Well, a lot of work went into this. The POC was, I think, built in 2 weeks. The iteration actually took 1 month. The results, we were able to go from an abysmal 35% accuracy to a 74 one. While the 74% looks good, it's actually the 35% that is more interesting. When the team came back to me with 2 big thumbs up, that was the vibe check number, 35%. So yeah, don't really rely on vibes. Yeah, that's really what worked for us. We learned a lot going through this journey, and we thought all of these lessons were really precious, right? So we decided to encode a bunch of these into our own AI agent development framework. I'm excited to present Sentinel. It's an AI agent development framework written in Java and developed at PhonePe. It's type safe by default. Structured outputs and prompts are a first-class citizen. And it comes with all the bells and whistles you would need from a modern AI agent framework. Let's see how you write a simple agent. So you actually just inherit from the base agent class that comes out of Sentinel core. You define your input, your output, the tools you want your agent to have, and additionally, extensions. I'll come to this later. So Sentinel is a multi-module project. What that allows you to do is pick and choose. So to write a fully functional agent, all you need is an LLM provider and Sentinel core. This gives you all what you need to develop an AI agent. What about the bells and whistles? All of them are extensions. These are separate Java modules that you can choose to add to your agent. Whether it be session management, agent memory, MCP support, or even skill discovery. Everything is an extension. Sentinel core, along with the extensions, make up your harness. And recently, we have also come up with a bunch of tooling to make sure that you can productionize your agent well. This involves an observability stack and the capability of writing evals. So yeah, to configure an extension, you don't really need to change your agent. All you need to do is configure your extensions, in this case, session and memory extension, and inject them in your investigation agent. So yeah, you don't really need to change your agent as such. Sentinel comes with compaction out of the box. You have to explicitly configure it, going on the same lines of no pre-baked magic. You can define your token budget and your threshold for compaction. Generally, I'd suggest you keep it at 60%. That's where the LLMs perform well. Post that, they become dumber. And yeah, so testing, you can write your evals. These may be deterministic evals, testing for confidence level to be more than 0.9, or they could be similarity evals based out of LM as a judge or embedding similarities. That's it. The key takeaways from this talk, keep it simple, prefer predictability over autonomy. While a swarm of autonomous agents solving for world hunger sound cool, predictability is what will allow you to sleep better. Focus on the boring stuff. I think you are adding non-deterministic stuff in your code. Make sure that all of the other things are rock solid. And optimize your context. This is not just about cost, it's also about the LLM performance. Thank you, and I'll take any questions now.